Not sure what this error is. It's interesting. Method has no argument. String greeting. Not sure what I'm missing here. Method should have self. Oh. Ay, ay, ay. Okay, there we go. Just getting started in, what's the problem here? Invalid syntax. Oh, capital. What? Dang it. Okay, give me a second here. Just getting rolling here. Is anyone here? Am I talking to myself? Oh, Chages, what's up, dude? How do I chat? Still figuring this out. We are doing, if you want to follow along, we're doing subsets. So if you search leetcode subsets, it should be the first problem. Let's see. Yeah. Okay, so search leetcode subsets on Google, and it should be the first link. If if you want to follow along. Okay. So the plan here is it's like 5. We'll go till 6. Just try and, I don't expect to finish 2 problems, but I'll like look at them and just hopefully at least get a plan for how to solve them and like, yeah, explain it in English at least. I haven't looked at this for about a year now, so getting back in the swing of things. Okay. All right. First things first, just trying to get something set up. Huh. Okay. Let's remove the types. Okay, so that works. But if I add types, it doesn't work. Not sure why. List int. Invalid syntax. Type hints Python. Let's see if I can just run this one. Greeting. I'll give it a name. John. What? Okay. I'm not really sure what's going on here. We're just going to get rid of the type hints, I think. Okay. Okay, so that works. Okay, so here is the problem statement. Okay. So, given an integer array nums of unique elements, okay, unique elements, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. Okay. The empty set, each one individually, all pairs. Okay, so let's figure out. So empty set, all of 1. I like to do it. My strategy is I like to just do it by hand and see if I can get any intuition about what we're doing, and then see if I can write some code to do what I was doing by hand. So the plan here is do it by hand. See if we can gain intuition. Translate that to code. Okay, so let's do it by hand. Now we want all pairs. So 1 and 2, 1 and 3, 2 and 3. And 3, there's only one way to get all 3. Okay. Okay. So 3 choose 0. 3, choose 1. It's all combinations of 0. This is all combinations of 1. 3, choose 2. These are unique combinations of 2. And then 3, choose 3. There's only one way. So that's like, I know how to get the number of subsets. But now the question is like, how do we get individual values? So let's think about this. Let's do one more, I guess. Yeah. Whenever I can't figure it out, I just do a couple more examples. Try and get this intuition. And we'll call this quits. So we're gonna try bang our head against the wall for 30 minutes max, and then we're just gonna look at the solution. That was my strategy when I was studying originally. So let's do that again here. So we're gonna stop at let's give it 5:30. If we haven't gotten a plan for what to write in code by 5:30, let's just look at the solution. Okay. 7-minute timer. Okay. Cool. All right. Let's think. So if I use one pointer, if I use a pointer, so I'm doing 3, choose 0. I'm going to say if it's 0, then, okay. There's 0 pointers. Now let's think about the case of one pointer. If you have one pointer, return a list of, each value that iterate over the list and return a list with each value you land on, right? So we return a list of 1, list of 2, list of 3. And now let's think about 2 pointers. Okay, so we got I and J. Is this going to work? Let's think. Okay. So we want to return a list starting from I and stopping at J. And we want to increment them both. Is that right? Yes, let's increment them both. Okay. 1 and 2, 2 and 3. Oh, okay. Oh, I think this is a brute force solution. Let's see. So, interesting. So increment J, that gives us 1, 2. This guy. Increment J, that gives us 1, 3. It gives us this guy. And now we've reached the end. So let's increment this. And if we say, don't look at, just skip whenever I equals J, we can say increment J. That gives us 2, 3. Okay. And now what's the plan for when we want to choose 3? Interesting. This is like n cubed solution. Wow. So it would be 2 for loops for each of these pointers, and then another for loop for the size of the input. So this is an n cubed solution. Okay, so what's a brute force solution? Let's talk about it so brute force. So the brute force is going to be something to do with 2 pointers. And also like the size of the input. So like for I in range len of nums, and then for J in J, find I, K. Okay, so this one is going to be okay. So size of input, first pointer. It's going to be the second pointer. Okay. So what is the plan? So, okay, so we're not sure of the specifics. Like, we have to handle like stop, start, and all that stuff. But we can talk about like the time and space complexity of this thing. So it's going to be, and let me bring this up here. This is kind of getting confusing. Okay. Brute force. Okay. So this is O of n cubed time and O of 1 space. Well, no, definitely not O of 1 space, because we're going to have to keep track we're going to use some intermediate space with this variable. We're going to append like these individual values to this output value. So it's related to, let's see, 1, 2, 4, 5, 6, 7, 8. Oh boy, is the space also n cubed? Dang. Okay, so we have some idea of like a brute force solution. We're not sure exactly how to mimic what's going on here. So basically, I and j, maybe we're going to skip when I equals j. Well, j in our case it's j and k. When j and k are equal, let's like skip that value potentially. Okay. And then increment. Then we want 1 and 2, want 1 and 3. And now we go, this goes back to 0, this goes here, but we're making sure that j is always less than k. So we're going to only look at this one. So 1 and 2, 1 and 3, 2 and 3. Boom, we got those ones. Now when we're getting size 3, how are we going to do this? It's like there's going to be some kind of an if statement here. If k minus j is greater than, I don't know, I or something like that. Out.append jk, nums j nums, something like that. I'm not sure exactly what this condition is, but it's something like that. Okay. Okay, so let's just do this one more time. So we start at 0, 0. All right, so we want to get this guy. So maybe we just start. Looks like there's always going to be this thing in here. So let me think. If I is 0, something like if k equals j, which equals 0, we're going to append an empty list. So that'll only do it at the first value. That's cool. Okay, so all right, so let's think about this. How are we going to get 1, 2, 3? So after the first loop through, let's see. Maybe we say next. It's going to increment j. But how do we pop out of this? We want to pop out of this guy up here. Okay, so somehow we're going to come back to that. Okay, so let's think. like this song. Okay. All right. We're just going to look at the answer here. So we got some kind of an idea about the brute force solution. I think it's going to be O of n cubed, time and space. So didn't get it fully, but we got some idea about the intuition about how we're going to do this. So let's just look at the answer. Okay. Okay. General, so let's just go with the top rated one. Okay. Backtracking. Okay. I don't think I've done many backtracking problems, so this is a good problem to do. But here I am just going to demonstrate subsets, permutations, and combination sum. Okay. Subsets. Okay, so we're going to sort it. Interesting. Backtrack. List, temp list, nums, start. Oh, that's cool. So if you want more practice, he's done all the other combinations of this problem with you. Interesting. All right, so let's just try and understand. Okay, so the way I like to understand code that like I haven't written is take it and walk an example through it. Okay, so let's just do solution.java. Okay. All right, let's run this example through it. This is we didn't get this one correct, but that's okay. We can still learn from it. So the plan here is we're going to walk through this example. Okay. All right. So we've got nums, we've got this output. We're going to figure out how do we get from nums to this output. Okay. And this is going to be, like this code will be our guide. Let's okay. Oh, wait. Crap. Okay. Let's go like that. So it looks like backtrack is, okay, it's just modifying this list. It's not returning anything. Okay, so we're going to keep track of a couple things. Say list. List starts off as an empty list. This is nums. Okay. The idea is we're going to walk through turning this input into the output and just see how the intermediate values change. Okay. We're going to sort nums. Okay, so it's already sorted 1, 2, 3. Okay. Now we have a couple more variables to keep track of. Temp list. Okay. And start. Starts off as 0. Easy line. Okay. All right, so what are we going to do here? So we have list, and list is what we're going to eventually return here. First we have to run it through this backtrack function, and then we're going to return it. So list, temp list, nums, start. Okay. Okay, we're going to add temp list. Okay. Temp list is empty. All right. Next, what are we going to do? Okay, I. Nums.length. Okay, so let's keep track of I. I starts off at start, which is 0. Okay. Looks like we're going to do a recursive algorithm. We'll call backtrack again. Interesting. Okay. So you have to keep track of intermediate runs of backtrack. So it looks like this is going to get involved. So our goal is to try and get through this by 6. I've got 20 minutes. Okay. Backtrack. Return. We want to keep track of our returns. So go like this. Backtrack. Okay, our first input is list, an empty list. Temp list, which is empty. Nums, which is 1, 2, 3. And start, which is 0. Okay. We're going to keep track of each call to backtrack and figure out how is it changing our list. Okay, so we got to figure out what's happening with this one. Okay. Okay, so temp list. We're adding this empty list. Okay, got it. Now for I, in this case, I is starting at 0. And I is going to go till 2, 0, 1, 2. Okay, temp list, we're going to add temp list, we're adding nums I, which is 1. And now we're going to call backtrack with list, which is this thing, temp list, which now is this, and nums, which is still the same, and I plus 1. Okay. And this is going to be like return stack. So that means this is the first thing to be called. This is the second thing to be called. Yeah. We'll do a stack. Easy align. Comma. How do I do this? No. Oh yeah, cool. That worked. Cool. Okay. And we have not gotten to this part yet. Okay, so now we're going here. And man, this is super confusing. Yeah, the recursive part is throwing me off, and I'm not sure how Java does scope. Like if we change temp list, like within one of these calls to backtrack, does it affect like the original one, man. So I would like to see an iterative solution first before I try and understand this recursive solution. Yeah, that makes it a little tougher because you got to know about how Java handles scope, like variable scope. If we're changing list with inside this one, is that going to change the global one? It's just confusing. Let's see if we can find an iterative solution. Bit manipulation. Okay, he does both, so that's nice. Okay, so what is he doing? Okay, this is the recursive backtracking. Iterative, using 1, 2, 3 as an example. Iterative processes like initially one empty subset, adding 1, adding 2, adding 3. What? Okay, let's try this one. See if we can make sense of it. How do you do a C++ comment? Two slashes. Okay. Okay, so all right, let's walk through this. We got nums, which equals 1, 2, 3. Subs, which equals just an empty list with an empty list. Okay. So we're going to iterate over nums. Cool. Okay. We're going to use I to keep track of where we're at. N is going to be subset size. Size of this is 0. Let's see. Python. What is the len of an empty list? 0. What about the len of an empty list with an empty list inside? 1. Okay. N, we're going to keep track of. N is this subset size, which is 1. Okay, so we've got so many overlapping things here. Let's call this N. Let's call this, let's just call this size. 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 I. Wait, what did we mess up? Okay, so we need to do, we need to change all occurrences of N. Let's search for N and replace it with size. No, yes, no, yes. Okay, that should work. Okay, so let's call this size. I want to make sure that I can, like, keep track of which variables are tracking what. Okay. I, and then let's call this num. It's called numx. Search for num, replace with x. Yes, no, yes. Okay, x, x. Okay, so we got xi and size, subs and nums. We're going to keep track of these variables as we walk through. Okay, for x and nums, x starts at 1. Size equals subs.size, which is 1. We confirm that here. Okay. All right. For I equals 0, so I starts at 0. We're going from 0 to 1. Subs.push back. We're going to push back, push back subs I. Sub 0, oh, what the? Okay, so sub 0 is that. Okay. Subs back, what is this? Oh man, I don't know C++. Vector back, C++. Returns a reference to the last element in the vector. Okay. Subs, the last element is this thing. And to this we're going to push back x, which is 1. Oh, interesting. So back, interesting. In C++, back is the last element of a vector. Reference to the last element in the vector. Okay, cool. Is a reference. Okay. This is what we got so far for subs. We need to iterate I. I is going to here. It's now 1. Okay, so this is x. I is, I mean, we can add, okay, let's go like this. We're going to add just the indexes of each of these, 0, 1, 2. And I start off as 0. We're going to increment I as now 1. Okay. So these numbers are the indexes for nums. 0, 1, 2. Okay. Increment I. I is now 1. I is not less than this, so we exit out of this for loop. We increment x. And size equals subset size. Okay, so this is 2. Let's just check. Len 2. Okay. So now size is 2. 2. Okay. And now what? And now I starts back at 0. Subs.pushback subs I. Wait, subs 0. Oh, okay, empty one. Add an empty one. And now get a reference to the last element, so this guy, and add to the last element x, which is 2. Okay, interesting. Nice. Now increment I. I is now 1. I is still less than 2. So we push back like this. What's up, Christopher? Welcome. What's up, Jay? So we're just, sorry, catch you guys up. We're just going through the solution for subsets. I came up with some kind of a brute force solution. I couldn't code it up. So now we're just going through the solution. I'm going through. So you, on the problem, you just click discuss. And I tried this one first. It's recursive. I couldn't figure it out. So I'm looking for an iterative solution. So I'm going through this solution right here. I like to go through like top to bottom based on votes and views. gives you some indication of the quality. So just working through that right now. And the plan is we're just gonna keep track of intermediate variables. So what are the variables? You know, nums, x, subs, I. Yeah, so just keep track of these as we walk through. And the original input we're going through is 1, 2, 3. So the input here is 1, 2, 3, and the output is this guy right here. So kind of at the beginning, we've gotten to here. And so we've got a few more iterations through the loop to go. Okay, so where were we? So I is now, at this point, I is 1, x is 2. So let's turn this off. Okay. X is 2. Okay, so where were we? Okay, subs pushback, subs 1, 0, 1. Okay, so we're adding this guy. And now subs back, we get a reference to this list of 1, and we're going to push back, we're going to add 2 to it. 2. Okay, and now what? Now we're going to increment I. I is now 2. And I is no longer less than 2. So we're going to exit out of this for loop. We're going to increment this for loop. Now it's at 3. And in this case, our size is now updated to 1, 2, 3, 4. 4. Let's just confirm. Copy that, len 4. Okay. So size is 4. I is going back to 0. I is 0. What else? Okay, I is going until we reach 4. So it's going to be 0, 1, 2, 3. Okay. Subs push back subs 0, which is an empty list. And we're going to get a reference to this guy right here, and we're going to push back 3. Okay. Now we increment I. I is now 1. And we're going until 3. Interesting. Let's just add 3. 3. Okay. So what is this? Let's label this. It's just I. Index. Keeping track of our index here. Okay. And this is useful, having this lined up a little bit. So this is 0 index, 1 index, 2 index. Okay. So I is 1. We're going to push back subs I. Push back this guy. Interesting. Wait, what? Hold on. So we just pushed back 3 here. We incremented I to 1. Now we're going to push back this. Okay. And then get a reference to this guy and push back 3. Okay, I guess that makes sense. Now increment I. I is now 2. Now we're going to push back subs 2, 0, 1, 2, 2. And we're going to get a reference to this list, and we're going to push back 3. Interesting. Yeah, I don't know. This would be a tough one to like get the intuition of. I don't know how you could intuit this one. I think you just have to do a bunch of problems and understand this is what the algorithm is. That's okay. LeetCode has a bunch of problems to practice with. Okay, so 2, 3. push back x. Okay, increment I. And now we're here. Now we're going to push back subs 3. So subs 0, 1, 2, 3. 1, 2, 1, 2. Okay, we're going to get a reference to it, and we're going to push back 3 to this thing. So 3. Okay, so we're done with that iteration. I is now 4. I is now 4, and I is no longer less than size. So we're going to exit out of this loop, and we've also reached the end of this loop. So we exit out of this loop now, and we're returning subs. Does this look correct? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so usually, I mean, I would say like half the problems you can just get some intuition about it and understand. This one was not super intuitive. It's like, So we're always starting at 0 here. So we're always starting with an empty list. Interesting. Yeah. I think this one, to understand this backtracking thing, you just have to do a bunch of backtracking problems. So I would search like leetcode backtracking. And I would search by difficulty, and I would start after the easies and just try and do like 5 problems. Go back and see if it makes more sense. If not, that's okay. Come back and do 5 more problems. Okay, so that's what we got today. We got what were we able to do? Not too much, and that's okay. You know, it takes a lot of iterations through to get the feel for these types of problems. I think the key is just to remind yourself like you're not dumb when you don't solve it. Just get a little bit better every single time and keep grinding away, and eventually you get better at this type of stuff. So where am I at? Just self-assessment. So I had some idea about a brute force solution. I couldn't come up with any kind of an optimized solution. So the optimal solution here, so let's do this time and space complexity of this. This is, okay, so this loop is an O of n loop. This is another O of n loop. So this whole thing here is going to be, O of n squared time, and what's the space of this thing? We're keeping track. This is the extra space we need. And how big is subs? Subs is like, I guess, O of n squared space, because we're adding a new value to subs every iteration through. So this, in this case, time and space are the same. So it's O of n squared time and space. I don't know. Do you guys agree with or disagree? Let's see what the chat says. Subsets, yeah. So the problem number, so to find the problem number, just search subsets, leetcode, and it'll be the first link. Okay, so I did not solve this problem, but that's okay. I had some idea of a brute force solution, not great. Some idea about an O of n cubed solution. The optimal one is O of n squared. It looks like time and space, unless you guys disagree. Let's see if it says here. He's not telling us the time and space complexity, but it looks like to me O of n squared time and space. Let's see if we can search for this. O of n. Okay. 2 to the n, they're saying? O to the 2 to the n? Maybe. I don't know. O to the 2 to the n, apparently. Not sure. Anyways, the plan is try and do 1 hour a day till we get back in practice for things. Accept that you're not going to be amazing at this type of stuff to start. Just, remind yourself you're not dumb when you get this wrong. And here's a perfect example. I just did this one. I did not get it correct. But I'm reminding myself I'm not dumb, even though I didn't get this correct. I walk through a solution by hand, keeping track of these intermediate variables. This is my personal strategy for learning code that doesn't make sense to me. And now my plan is to start off with, so I found out this is a backtracking problem. How can you see related topics? Okay, so I know it's backtracking. So, all right, I don't know about backtracking. So let's search backtracking leetcode. We go to the first link. We're going to sort by difficulty or acceptance. Probably difficulty. And I'm just going to do like 5 to 10 problems, then come back to this problem and see if it makes more sense after getting some practice with it. So the idea is just figure out where you need some work, go get some practice, go back and test yourself again. And just keep going back and forth between testing and practicing. Testing, practicing, testing, practicing. And this is a good strategy. There's others out there, but one strategy is to keep track of intermediate variables and see how they're changing as the input gets transformed into the output. In this case, input is 1, 2, 3. Output is this list of lists or vector of vectors. Yeah, that's all I got for you guys today. Any questions or any feedback? Is this valuable to you guys? That's a good question. Nice. Sweet. Anyways, that's all I got for you for today. Plan is to come back and do the same thing again tomorrow around the same time, like 5 p.m. Pacific time, 8 p.m. Eastern. All right, guys, thanks for watching. Have a good rest of your night.